Okay. All right, we're recording. Yeah. All right, this is logarithmic functions. All right, so write each equation in exponential form. We already did number 3. This is log form. Exponential form would be 2 to the 5th equals 32. Rearrange. All right. Yeah, we'll start with you. All right. Rearranged works that way. 9 to the 5th. You know what? I did not know that 9 to the 5th was that, but I'll say cool. Malachi number 11. There we go. When you put a negative exponent there, it puts it down to the denominator and makes it a really small fraction. Now, numbers 15 through 27, we're writing the equation in the log form. So it's in exponential form, going the other way. We'll start right there with Josh. Well, it's 3. I don't know why I wrote a 8. Log base 8, 512 equals 3. Rearranged properly, good job. And then, Logan. Log what now? Log base 5. 625 is the value, equals what? 4. There we go. I know y'all can read this really well. That's awesome. Let's go to Wesley. Base 8, 1, 8, negative 1. There we go. And lower log what? Base up. Okay, there you go. Good job. You'll rearrange those the right way. I'm going to come down here and evaluate these. Two. 2 squared is 4. I agree. Malachi? Negative 2. Very good. Josh? 2 again. 11 squared is 121. I think I know this one. What is it, Logan? What was it again? 6 to 7.75? Try it again. And your calculator can't lie to you if you just type it in right. I don't think it can lie to you. Maybe it can lie. Ah! I'm making a mess up here. What'd you get this time? That makes more sense. 6 to the 3rd power is 216. Wesley? I had a feeling you were going to say negative 2. And I have a feeling Laura's going to say negative 2 as well. Down here on these graphs, I'm just going to show them to you. The first one, that is the inverse of 6 to the x, which is a growth curve, crosses at 1. So if we go to our screen, let's go menu, actions, let's delete, clear that off, menu, graph entry, a function, control, log, 6, x. There is the log equation. It does not have any vertical or horizontal or vertical shifts, correct? That is simply the inverse of a growth curve. Notice it crosses this x-axis at 1. Its inverse would be a growth curve crossing the y-axis at 1. It's not been shifted any. This next one right here, just going to go back and change this curve. This one I'm going to expect it to be shifted which way? Down 3, that's not in with the x. That would be a right 3. Let's see if I can adjust this graph. I'm just going to go over here, adjust that. What's the base now? 2. Minus 3 is on the outside of the parentheses, right? So watch what happens. We expect that'll make the curve go down 3. And it did, and it had a little different curvature to it. So it's inversing this. If you were to put 0 in for x, you would have 2, let's see, 1, what is 1 minus 3? So it's reflecting a curve that would actually have been right here. Oh, you can't see it. No. It would have been right there. But ain't it nice to use your calculators? Why is that blinking at me? I don't know what it's doing. Quit blinking. Calculators is a tool you can use on your ACT, and it helps you be able to see what to expect on any kind of function. All right, let's change it one more time. For this, if I give you one of these on your test, I'll give you a coordinate plane. You use your calculator to get the position where the curve is supposed to be and make sure you graph it appropriately. Keep it simple. We're going to leave the base the same. This is going to be plus 1 now, and in here we would have a minus 3. So we expect it to be 3 to the left, or 3 to the right. I said it wrong, didn't I? 3 to the right and up 1. And there it is. We now have your vertical asymptote was the y-axis before. Now it's going to be x equals 3. All right. That's all those.